Hello my dear students, let me welcome you for this physics class of the e-learning which is sponsored by the Orissa Government of Orissa. Today we are going to discuss about one of the interesting and most of the vital chapter in the physics which is called the current electricity. And as per the units which is mentioned by the CHSE in the revised syllabus, you have in the unit 1, that is the electrostatic. That unit 1 is already completed for you. So, that is the electrostatic and this is the current electricity. That electrostatic, it contains the word of the electro and the static. That means electrons at the rest, that is known as the electrostatic. Electrostatic, which is the combination of the two words. One is the electro, second one is the static. And here we are going to discuss about the current electricity. So, it also contains the two words. One is the current, second one is the electricity. And these two words are quite familiar with us. The current word we are using and we are thinking in a one way, but saying in the another way in our the common language. Suppose there is no supply of the current due to the some hazardous conditions like the heavy rain or the flood or the typhoon likewise. So, at that time we are talking among ourselves that the line is not there, but for the conceptions I will clear that that is not the line, that is called the current. The current is not there. तेणु ओडिया रे आमे कहूचे लाइन कटि जाइछि, एटा गोटिए भूल शब्दटी को आम भाषा भितर आज आमे ग्रहण करि नेछि, व्हाट एवर इट मे बी. सो दिस इज द करंट एंड द सेकंड वन इज द इलेक्ट्रिसिटी. सो व्हाट इज द मीनिंग ऑफ द इलेक्ट्रिसिटी? The electricity is that type of the energy which is produced from a fundamental particles. That fundamental particles like the electron or the proton. Electron or the proton. These fundamental particles, the energy which they provides, the energy it is nothing but the some type of the work done. So, here some work is going on and that work is taking place by means of the current. Therefore, we are saying that this is the current electricity, but the earlier one is the electrostatic. Electro means the word of the electron and static means the rest. So, the basic difference is there the electrons at rest and here the electrons are in the motion. Due to the motion, the nature which they produces, that is known as the current, which we will discuss after some time. So, if this is the current and that current takes the important role in our day to day life. So, that important role is that one, whatever may be the instruments we are using day to day for the easiness of the life maintenance, and each and every one is concerning with the current. And if the current is not there, then that instruments will not the function. Suppose I will give you some of the examples. Likewise, in the screen you can observe very clearly that one is the electric heater or the electric room heater, or one is the iron. Suppose the kettle, electric kettle, like the TV, like the sound box, everyone is functioning with the electric current. So, that electric current is what we have to discuss now. So, the current as per the syllabus, you know in the school level also, and you have some idea about the current, and that current in our the own language, that is known as the Vidyut. So, what is the current? It is defined as the rate of flow of the charge. So, this current is defined as the rate of flow of charge. So, this charge, as you know in the earlier chapter, that is of the positive or the negative. The negative is the electron, the positive is the protons or the positive charge carriers, that we know. So, the rate of flow of charge is known as the current. So, this current is defined mathematically. This I, current is represented by the I is equals to the dq by the dt, or that is equals to limit of del t tends to 0 del q by the del t. So, what is del q and what is the del t? Del q is the small charge. This is the small charge and this is the small time. So, if you take at any time what is the current, then that current I is equals to limit of del t tends to 0, del q by the del t. Otherwise, this I is also equals to the q by t. Means q is the charge and t is the time. So, q upon the time, that is equals to the current. So, this q is what? That is the charge which I written here, that is the charge. So, charge means is what? The charge means it is the assemble of the electrons. So, this charge q, that is the assemble of the electrons. Assemble means more than one. When more than one electrons are taken together, then that is known as the assemble. As you heard the word of the assembly, which is present in your the Bhubaneswar, the assembly session is going on, means it is your the collection. So, this is the collection of the electrons is known as your the charge. So, if E is the charge of the electron, and about the charge of electron, you know that is 1.6 into 10 to the power of minus 19 coulomb, that is in your the MKS. But if we go for your the CGS and the EMU, it also has its the different values that we know very clearly, and we will discuss also that one. So, Q is equals to NE, that means this Q value if we substitute, then I is equals to your the NE by T, or this N means your the number. Here I am taking the total number is the capital N. You may take it as the small n, whatever may be the notation you will use here, but that will correspond for the total. So, total number of the electrons divided by time, that is your the current. And next we will discuss, if the current is there, then what will be its the unit. So, now we will discuss what will the unit and dimension. What is the unit and the dimension of your the current? So, you know very well that to find the unit or the dimension of your the any physical quantity, we have to first know its working formula. If the working formula is known to us, then we can easily find out what will the unit and the dimension of any type of the physical quantity which is present. So, here we are interested to find the unit of the current. So, first you will think what is the definition or what is the mathematical expression of the current. The current mathematical expression as we have written here, that is equals to the Q by T. Then what is Q? Q is the charge and the T is the time. If Q is the charge, then what is the value unit of the charge? In that respective system, we have to first think. So, when we are going to find the unit, let us go for here the MKS, and we know there is a CGS, and third one also we know as your the physical physics, that is your the FPS, but we are mostly using of the MKS and your the CGS. So, if we go for your the calculating the value of the unit in your the MKS one, the charge is equal to I is equals to the Q by T. So, here according to the formula, Q is the charge which is your the coulomb, 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 and it is commonly written as the COL with your the dot, that is the coulomb. So, if Q is the coulomb and the second factor is your the time, and the time is your the second, then it is the unit I is equals to your the coulomb by your the second, and this coulomb by your the second has a definite name, that is called your the ampere, and it is represented with a symbol by like your the capital A, that is your the ampere. So, this is for your the MKS. And if we go for your the CGS, and here in your the current electricity, it is divided into your the two types. One is your the ESU, one is your the EMU. So, ESU means electrostatic unit, and this is equals to your the electromagnetic unit. you have some idea in your the previous chapter. So, electromagnetic unit means due to the flow of the current, it produces here the magnetic field. So, when the magnetic field is created, the respective unit of your the CGS is called as your the EMU, electromagnetic unit. So, according to this one of your the ESU, the current I is equals to your the charge by your the time. So, here the charge will be your the start coulomb, and the time is your the second, that is equals to your the start ampere. And for your the magnetic one, that is equals to your the half coulomb, you know very well in the previous chapter, that is your the 1 half coulomb by your the second, that is equals to your the half ampere. So, these are the units of your the current. In M case, that is your the ampere. In CGS, that is equals to your the two types. One is the ESU, second one is your the EMU. So, it also has the relations among them. If we will go to find the relation between your the ampere and your the start ampere, relation between ampere and start ampere. First, you have to take in the M case. So, that is equals to your the ampere is equals to 1 coulomb by your the 1 second. You see, ampere is equals to 1 coulomb by your the 1 second. And when we are wants to convert ampere to your the start ampere, this coulomb to be converted to your the start coulomb. And you know very well that 1 coulomb is equals to 3 into 10 to the power of 9 start coulomb, and this is your the second. So, you see the start coulomb by your the second. Start coulomb by your the second is the start ampere. So, this is equals to 3 into 10 to the power of 9 start ampere. So, 1 ampere is equals to your the 3 into 10 to the power of 9 start ampere. Then we will go for your the relation between your the ampere and half ampere. So, this ampere and half ampere means 1 ampere is equals to 1 coulomb by your the 1 second, and for the half ampere it is the half coulomb by your the second. So, coulomb to be converted to your the half coulomb, that is the 1 by 10 of the half coulomb. 1 by 10 of half coulomb is equals to your the 1 coulomb by your the 1 second. So, half coulomb by your the second, half coulomb by your the second is the half ampere. This 1 by 10 will go down. So, 1 by 10 of your the half ampere. So, these are its the units. Next, we will go for its the dimension. So, to know the dimension of your the any physical quantity, my dear students, this is my the kind request. To find the unit and the dimension, you have to not make it the by heart. If you remember the formula, you can easily find the unit as well as the dimension. For the dimension, we have to remember it's the formula. So, formula is equals to the Q by T. Q is the one of the fundamental. That fundamental is represented with its the dimension as the Q, and the T is also the fundamental, that is your the T. So, this is equals to your the QT inverse. Or though this is equals to your the I means your the ampere, ampere is starting with the letter A, this can also be written as your the A. So, A. So, either you will write the dimension means it is the symbolic representation. So, by the symbol it can be represented with the A, or in terms of the Q with your the T inverse, that is its the unit. Next, if it has its the unit, then we will discuss about its the direction. So, what will be the direction of the current? Direction. The direction of the current is always, it opposes the flow of its the negative charges. If due to the negative charge flow the current is considered, or due to the positive charge flow the current is considered. Suppose this is a conductor, it has your the negative charges. If the negative charges are flowing from my left to your the right, then due to this, if you will connect with your the some source and some current will flow, then the current flow just it's the opposite. If these are it's the electrons, so electrons opposite direction. If the electrons will flow in this way, if the electrons flow, then the current flow in its the reverse direction. Suppose this end is the A and that end is your the B, and if the electrons are flowing from A to B, then the current flow from B to A. Instead of the taking the electron, as I have said that the charge particles, if we take these are it's the positive charges, these are the positive charges, and the positive charges are flowing in this direction if, then the current is also flow in that direction. So, you have to remember that the current flow either in the direction of the positive charge or the current flow is in the opposite direction of the negative charge. Suppose I will ask you one question, a current is the charge is flowing from north to south, then what will the direction of your the current? Then you can say easily that it is from your the south to your the north. Suppose the electrons are flowing from your the right to left, then what is the direction of the current? From left to right. Suppose the current is flowing from your the east to west, then what will the direction of the electron? Then that is the west to east. But what is the direction of the positive charge? That is your the east to west. So, this is your the direction of your the current, which is called it's the conventional current. So, as we discuss the unit and the dimension of the current, and next we will discuss about the some numericals regarding to this one. So, you know very well that when you are reading the +2 science, you are giving the importance for your the entrance coaching. So, for your the entrance, the various types of the numericals are coming. So, one of my request to you, if you will remember what I am saying regarding for your the any numerical, it will help you in future. To find the numerical solutions, we have to remember a formula which is called, in my sense, that is the Pandava formula. So, if you remember the Pandava formula, then you can easily solve out any type of your the numericals. Suppose I will give you one of the numericals which is looking on your the board, on your the screen. So, it is written that if you pass 500 milliampere of the current through a bulb, how many electrons will pass through it in 5 minutes? This is the question. So, the numericals to solve the Pandava formula means there are the 5 steps. The first step is, first you go through your the question and understand its the meaning in your own language. निज भाषा ताको आगे बुझा. Second one is, whenever a numerical is there, it must provide with the certain datas, and you have to write the datas with here the symbols. As I have written, for the symbol of the current is the I, for the charge is your the Q, the number is your the N, for the time is the T. Likewise, you have to write its the symbols. The third one is, whenever a numerical is there, something to be or the find out, and what is requiring to find out, you write that one, that is the third step. The fourth step is the most important step. What are the datas are given in your the second step, and you have written, and they are in the same unit or not. Same unit means completely in your the MKS or completely in the CGS. If they are completely in the one system, then it is your the OK. If it is the assemble of the different systems, means some datas are in the MKS, some datas are in the CGS. So, that is your choice. Either you will convert all to your the MKS or all to your the CGS. So, that is the fourth step. And the fifth step is put the answer and get the formula. Are you agree with me? No. So, that is not that sentence. You have to put the formula and you have to get the answer. So, these are the 5 steps. Again, I am saying the first step is the go through the question, understand its meaning. Second one is the write its the values with its the symbols. Third one is what is asking, write with its the symbol. Fourth one is either the given datas are in the same unit or not, that you have to observe. Fifth one is the put the formula and you the get the answer. So, as per the question which is looking before you, if you will go through that question, so if you remember what I said, when I am erasing this whiteboard, you just think over your the problems, what is written on your the screen, that is your the solution. How will you find the solution? So, first one is, you will go through your the question and you know what is its the meaning in your the own language, the what are its the given datas. According to the question, the data is your the 500 milliampere. So, ampere is your the current. So, 500 milliampere means that is the current is your the 500 milliampere. Then what the second thing is given or not is there, then in your the 5 minutes. So, minutes means your the time. As I said, what is written, it is the symbol, the time is your the 5 minutes. Then another thing is, within the questions, but the value is in your the erasing position. So how many electrons will be there? So electron means your the E, it has its the charge 1.6 into 10 to the power of minus 19 coulomb. So these are the data which is given according to the second step. The third step is the you have to find what is asking. So what is asking? How many electrons? So many electrons means, as I said, the number of the electrons. So number of electrons is the capital N, that value you have to determine. So these are your the data. This is your the asking one. First step is your the you already gone through your the question, and the fourth step is either they are in the same unit or not. You see, as we discussed, coulomb is in your the M case, but this is your the milliampere, not in your the ampere. So you have to make it to your the ampere. For the ampere means this milli will be the 10 to the power minus 3. So with your the A. So this is your the ampere, means this is already in the M case, this is already in the M case, and the time is always in your the second. So 5 minute means your the 60 second. So that is equals to 300 second. So all are in your the same unit. The fifth step is the put to the formula, get the answer. So these are the given, this is your the asking, and what is the formula as we discussed? I do remember yourself, and that formula we have written I is equals to your the NE by T. I is equals to NE by T means N is your the number, that number is your the asking, so that N will remain N. E is the charge of electron, 1.6 into 10 to the power minus 19, by T is your the time is given here the 300 second, and this I is already given here the 500 into 10 to the power of minus 3. So the question is asking for your the N, that implies N is equals to your the 500 into 10 to the power minus 3 into 300 divided by 1.6 into 10 to the power of minus 19. And if you will solve this one, or you will simplify that one, then you will find the value of your the N. So this is your the numerical. Likewise, if the numericals are provided, then you can find its the value by putting as per my the formula, that is the Pandava formula. So my request is, you have the number of the problems in your the task books, so you will go through one by one and try to solve that one. So next we will go to discuss about your the next one, that is your the drift velocity. The one is your the drift velocity. So regarding this velocity, you know your the different terms, like your the terminal velocity, orbital velocity, angular velocity, different velocities you know. So this is your the drift velocity. This drift velocity is only arises, suppose this is your the conductor, and it has your the electron, say. So when some electric field is applied by just joining with your the source, then these free electrons which are present in your the conductor, they to be the start accelerating. Due to their acceleration, these electrons will bombard with themselves. Means if you have your the number of your the electrons, if you will start about your the one electron, and if this electron is in the motion, suppose it is gone there and it make a one bombardment, then it will bombardment with that one, then with this one, then with this one, then with this one. So such type of the bombardments are going on among these electrons. So when these among these electrons the bombardments are going on, their numbers are the so high. So when the numbers are the so high, if we look for that one, they all are looks like to be at rest. As I will give you one of the example, during the car festival, when the lakhs of the peoples are gathered there, and the lensman is making your the camera to be focusing towards that one, and all the people who are present there, they looks like at the rest. but if the camera will go to the near and near and near, and you will observe that someone is going to some direction, someone is making the pickpocketing, someone making the someone, and someone making the clapping. So they are in the motion, but as we are observing from the large distances, there looks to be the rest. Therefore, due to the bombardment or the collision among themselves, they have the initial velocities of each of the electron is the 10 to the power of 5 meter per second. Such type of the velocities they have, but due to the number of the collisions among themselves, these velocities are gradually decreasing. So each one of the electron, if it has the number of the electron, the average of that all electrons while they are moving from towards the positive terminal of the conductor, then that one will be treated as it's the drift velocity. So drift velocity in physics, it is defined as that the average velocity already a charged particle which will possess such as the electron in a material due to the electric field. So due to this electric field, when these electrons are there, their average velocities if we calculate, that average velocity means if Vd will be the drift velocity, Vd, this if you will return as the drift velocity, V means velocity, D means the drift, then this drift velocity is the average, means the number of the electrons we have taken is the n. For the average, this will be the V1 plus V2 plus V3 up to plus Vn divided by n, that is treated as it's the drift velocity. As we discussed the definition regarding the drift velocity and what will be its the mathematical expression, we have gone through or we have written that V is equals to the V1 plus V2 plus V3 up to plus Vn by the n, and that V1, V2, V3, V4 that we have to calculate now. This is the electrons, and this conductor of length L, let it connected with the two ends to a source. So due to this source, these electrons to be the accelerate. So we have discussed that the number of the electrons are so high that their mean velocity at its initial position. If initial velocities are the u1, u2, u3 up to the un, and regarding them the final velocities are the v1, v2, v3 and the vn. These are its the initial velocities and this is its the final velocities. So you know that v is equals to the u plus at. This is the from the equations of the motion we know that v is equals to u plus at. V to make outhi na 80. V is equals to u plus 80. If v is equals to u plus 80, for the first one, v1 is equals to u1 plus a1 t1 and v2 will be the u2 plus a2 t2. Likewise, we have here the n. So vn is equals to un plus an tn. So as we have written that Vd is equals to V1 plus V2 up to plus Vn divided by n. So this V1, V2, V3 up to the Vn will be substituted there. When we are going to substitute, we have to discuss about here the A1, A2 and these values. So when this charge being this source being supplied, then these charges to be accelerate. Then if the acceleration is equals to A, due to the application of this potential and the field which is produced, that is equals to the F, and m is the mass of an electron, then you know that F is equals to ma. So A is equals to the F by m. This F is the electric field. As per the earlier chapter of the electrostatic, you know that E is equals to the F by Q. So F is equals to the EQ. So this F will be the EQ by the m. So this is for the remembrance. E is equals to F by Q. Also this E is equals to electric field, and you know that electric field E is equals to potential difference into its the distance, and this distance we have taken as the L. So this is equals to the VL. E is equals to VL. So, here E is equals to your the VL. Suppose you will substitute V is equals to your the ED, means this is equals to your the EL. So, V is equals to EL means E is equals to your the V by your the L. So, if we put the value of the E is equals to your the V by L, so V by L of your the Q by your the M. So, this Q is the charge. Here we are discussing for an electron. Therefore, this charge Q is equals to for an electron. This is equals to E by your the ml. So, A is equals to VE by your the ml. So, if we look for this one, V is your the potential. The potential which is applied, that is a constant one, and E is the charge of the electron, that is also the constant one. This M, mass of an electron, that is also a constant one. L is the length of the conductor which we have taken, that is also a constant one. Means all these values are to be the constant. Means the acceleration of an electron when they are bombarding with the others, the acceleration of the all electrons to be the remain constant. Therefore, for first electron V1 is equals to U1 plus A1 T1. This A1 T1 will be your the value, A2 V2 value, AN value. These all values are to be the constant. Therefore, if A1 will be the say A, then this is equals to T1. This is equals to U2. A2 is also equals to A1. That is also the same as that of the A. So, that is equals to AT2. So, likewise, this is equals to your the UN plus ATN. So, if we put these values here, you see V1 is equals to your the U1 plus AT1, V2 U2 plus AT2 plus dash 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 plus UN of UN plus ATN divided by your the N. So, this is equals to U1 plus U2 up to plus UN. I have taken all the first terms together, U1 plus of U2 plus of up to UN, U1 plus U2 up to the UN, then 81, 82, 83. So, all have your the A to be your the common. So, when A taken common, this is equals to T1 plus T2 up to plus Tn whole divided by your the N. When the two things are added divided by N, if we simplify them, then that will be the first by your the N and your the second by your the N. This first by your the N means U1 plus U2 plus UN divided by N. This U1 is the initial, this is the initial, this is the initial. As we discussed that all the initial velocities are regarding to be your the remain constant, means that is equals to your the 0. Their average one to be your the 0. So, when the number of the peoples are together and if we look from the outside at the far distance, then it observe that they are remaining at the rest. Therefore, this one is at the rest, means this is equals to 0. And this A will comes out. T1 plus T2 up to your the Tn by N means all the times this is the mean. So, all the times mean is written as your the tau. This symbol is the tau. So, this is equals to A tau, where tau is equals to your the T1 plus T2 up to plus Tn divided by N is called as your the relaxation time. This is called the relaxation time. Therefore, your Vd is equals to your the A tau, and the value of the A is equals to your the EV by ml. So, A value is equals to your the EV by ml of your the tau. So, this is the mathematical expression of the Vd. Very simply you have to remember Vd is equals to the A tau, and for your the large extent the value of the A is equals to EV by ml into your the tau. So, this is the expression of the drift velocity. So, due to this drift velocity, when the electrons are in the motion, as we discussed that the rate of change of electrons motion will constitute the current. Therefore, this drift velocity has its the relation with your the current. So, next we will discuss the relation between Vd and your the current, means drift velocity and your the current. So, if drift velocity and the current, you know the current I is equals to your the q by t, and this q is equals to your the charge. That charge is equals to your the Ne by your the t. Clear, students? Then this n is the total number of the electron. This is the total number of the electron. So, if we take a small cross section of that one, this is the total conductor of the length L. If we take a small cross section of that one which has your the small n number of the electrons per volume, this is the n, small n means this is the number of the electrons per volume. Then this capital N, which is the total number of the electrons, n is equals to number of electrons per volume into volume of the conductor, volume of the conductor. So, number of the electrons per volume means this is the cross section, number of electrons per volume, that is equals to the n, and the volume of the conductor means this one is the conductor which is in the form of the cylindrical shape. So, whatever may be the form of a subject, then what will be its the volume, how will you find out its the volume, what is the basic formula? Never go through your the by heart, you remember that one. The volume of your the any physical quantity, and whenever we are calculating, that value is determined the base area into its the height or the length or the distance. This is your the fundamental one, area into its the height or the length. You see what is the area? Suppose the area of this conductor is equals to your the A, that is your the A, and your the volume means area into your the height or the length, and what is the height or the length it is covered, that is equals to your the L. So, this number of the electrons per volume is equals to your the n of your the Al, and this q is equals to your the Ne. So, n value is equals to your the small n Al. So, this capital N value is equals to your the small a L of your the E by your the t. This t is your the time, and you know that V is equals to your the S by t. So, if this is the t, then t is equals to your the S by V. This V is your the velocity, here the velocity is the drift velocity, that is the Vd, and S means your the distance, and what is the distance covered, that is equals to your the L. So, the value of a capital T is equals to your the L by Vd. So, this is equals to your the T will be your the L by Vd. So, this Vd will go up, therefore, this is equals to your the NaLeVd by L. You see NaLe, this Vd will go up, NaLeVd by L. So, now LL is the cancel, therefore, I is equals to your the NaVd of E. So, I is equals to NaVdE. So, this N means your the number means it is a constant, A means your the area, that particular conductor which we have taken for that sense, that is equals to the constant, E is the charge of the electron, that is also the constant. Therefore, we can say that I is proportional to your the Vd, means the current and the drift velocity, they are directly related. If the drift velocity will increase, means the collision of your the respective electrons will be the more, then the current produces will be the more. So, I is equals to your the NaVdE. This is the relation between the current and the drift velocity. So, by putting this expression, you can go through your the task that if Vd is the drift velocity, this Vd will be your the I by your the NaE. Suppose one have remember the Vd is equals to this one, and one have remember Vd is equals to EV by ml into tau. These are the two different expressions, you just look on your the screen. So, if these two expressions are the different, if we put its the values or its the unit, you will ultimately find that the unit of this Vd and the unit of this Vd are also your the same. This is for your the home task, you can calculate in your the home also. So, this is your the drift velocity. So, next we will go for its the mobility. Mobility. So, what is the meaning of the mobility? As per your the name is designed so far, means the mobile. Mobile means it is the motion. So, due to the motion of the electrons and the electric field which we have already applied, then they have a relation among themselves, and the ratio of the drift velocity of the electron with the electric field, that one is known as the mobility. So, mobility is defined as the ratio of the drift velocity with the electric field intensity or the electric field, whatever you will say. So, if it is the drift mobility, it will be represented by the symbol of here the mu, then mu will be here the V by here the E. So, mobility means due to the mobile, as you are using the word of the mobile. So, this is your the mobility. This mobility is your the mu. So, this mobility mu is equals to drift velocity by your the electric field. So, drift velocity by the electric field means if we go for its the unit or the dimension, then mu will be the drift velocity. So, velocity means that is the common velocity unit. Common velocity unit means your the meter per your the second. By your the E is the electric field intensity, as I have written earlier. E is equals to your the F by Q, the formula is that. So, E will be the unit, F unit by the Q unit. F unit means your the Newton, by your the Q units means your the Coulomb. So, this is equals to meter Coulomb by your the Newton second. This second will come down and this Coulomb will go up. So, MC by your the NS will be its the mu. So, that is its the mobility. So, if the mobility will be there and the electric field will be there, due to the electric field, the current and the drift velocity, they have here the relation. So, I is equals to NA VD E. This VD is your the drift velocity. So, NA, you see VD is equals to EV by ml into tau. So, this is equals to EV by ml of tau, then another E is there. So, this E will be multiplied. So, this is equals to NA E square tau by ml of here the V. So, this implies I is equals to N constant, A constant, E constant, tau, ml, they all are the constant. That constant is taken as 1 by R of here the V. So, this implies V is equals to here the IR. So, this R is equals to here the ml by NA E square tau, because 1 by R is equals to this much. So, R will be its reverse. So, reverse will be the ml by NA E square tau, and this is known as the resistance. So, this V is equals to IR, this is latter known as the Ohm's law. So, now we will going to discuss about the Ohm's law. So, you know in your the 10th class the Ohm's law, and on that Ohm's law you know that if the temperature will remain here the constant, then the ratio of the potential difference with the current is always bears a constant value. So, if the temperature is remains constant, that is the important of the Ohm's law. But generally the students are saying that what is the Ohm's law? V is proportional to your the I, by V is equals to your the IR. Similarly, another law we know that is the Hooke's law, and generally most of the students they are saying that the stress is proportional to strain, but that is not actually correct with 100%. The stress is proportional to strain if here the medium or within your the elastic constants. So, within the elastic limit the stress is proportional to strain. Similarly, for the Ohm's law, the V is proportional to I. Under that one, if the temperature will remain here the constant. So, why that temperature factor comes? Now, let us go as per our the earlier derivation. You see the resistance means here the R. R is equals to ml by NA square tau. M means here the mass of the electron, A means here the area of that cross section, E is means here the charge of the electron, tau is the relaxation time, L is the length, and N is equals to the number. So, from this it is clear that the resistance R is proportional to your the L, means L is the length of the conductor. That conductor we can vary, means we can take a small one, we can take a large one. So, if the small one, what will be its resistance? The made of here the same material, if we take here the larger one, the resistance will be not that one. Therefore, R is proportional to L, because L will vary according to the shape of the conductor. A means here the area. If the shape of the conductor means the length will be the vary, then also the area will be here the vary. So, this area is also vary, means R is proportional to your the L and R is proportional to your the A. So, from this it is clear that if the temperature to be your the remain constant, if the temperature to be remain constant, what happens for the length of the conductor? The length of the conductor to be remains the constant. As we know that if a conducting substance is taken and it will be put inside your the hot chamber, instead of taking for the 5 minutes, if you will put it for the 15 minutes, what you will observe that the length of the conductor now it is increases. The phenomenon which is used by your the blacksmiths, and they are introducing your the iron rod inside the hot chamber for your the half an hour, the 10 minutes or the 15 minutes, and then they are taking it out and they are hammering it. Therefore, the size of that one will be the vary according to the person which wants to make it in that respected form. Therefore, if the temperature will not remain constant, means the length to be the vary, according to its the area is also to be vary, so the resistance will be vary. Are you understand, my dear students? So, if someone will ask what is the Ohm's law, then you have to must say that within at a constant temperature only, the potential difference of a conductor and the current produces that I means potential difference and the current, they are related directly. So, V is equals to constant of the I, that is equals to your the R. So, V is equals to your the Ri. This R is the resistance, I is your the current, and this resistance R, it has its the unit. What will the unit of the resistance? And that question, when you will have that, then you will say that the unit of the resistance you know in your the lower classes, that is your the ohm, that you know in your the 10th class level. So, unit. So, according to my concept, how will you write the unit of your the anyone? From its the mathematical expression. If the resistance we want, then R is equals to your the V by your the I. This is its the mathematical expression. If we will go for your the M case, then V will be in the M case, I will be in the M case. V is what? Potential difference. Potential difference in M case is your the volt by I means your the current. Current in M case is your the ampere. So, volt by ampere is equals to your the ohm. So, if it is 1 volt by 1 ampere, this is your the 1 ohm, or if there is no value is there, volt by ampere is equals to your the ohm. So, this is its the expression, but how you will define it? The resistance of a conductor is said to be your the 1 ohm when the potential difference of the 1 volt is produces the current of your the 1 ampere, then that is your the ohm. This is for your the M case. If we go for your the CGS, as I said, it is of the ESU or of the EMU. And if we go for the ESU, then volt will be your the start volt by your the ampere will be your the start ampere, and for the EMU, this is the ab volt by your the ab ampere. So, if this is start volt by the start ampere, that is equals to your the start ohm. This is ab volt by the ab ampere is equals to your the ab ampere. So, these are its the different units in your the M case and in your the CGS. And if we go for its the dimension, then the dimension also depends upon the formula, as I said. So, R is equals to your the V by your the I. V means your the potential. So, potential formula is equals to your the W by Q, and I is equals to your the I is equals to your the Q by T. So, this I is equals to your the Q by T. So, W by Q, this Q by T divided means into T by Q, that is equals to W T by your the Q square. So, W is equals to the work dimension you know in your the first year, that M L T to the power of minus 2 T means your the time dimension is the capital T, and Q dimension as I said that is equals to the capital Q. So, small q square means capital Q square. So, when you put the dimension, mention it in a square bracket, then you will arrange first m, then L, then t to the power minus 2 t with t to the power of minus 1. This q will go up, so that is equals to q to the power of minus 2. So, m L t to the power minus 1 q to the power minus 2. Also you can replace it as I as you know that I is equals to your the q by t. So, q is equals to your the I t. So, I means your the ampere, T is the time. So, capital Q dimension can also be written as your the AT. So, this QT, if we substitute by your the AT, then QT to the power minus 2 means AT to the power of minus 2. So, this will be your the A to the power of minus 2, and this T will be your the T to the power of minus 2. So, this will be ML T to the power of minus 3, A to the power of minus 2. So, either this one, or instead of taking this one, you can also take q to the power of 2, whatever your choice. So, this is the unit and the dimension of your the Ohm's law. So, if we put the V versus of the I in a graphical form, V versus of the I, as V is the 0, there is no current. If the V will increase, there is. So, this is your the graphical form of the V with the I. So, if in a conductor the V and your the I, they will satisfy the Ohm's law, then that type of a conductor is known as your the ohmic conductor. And on increasing the V, if your the I is not your the increases, but not in your the same proportion, then that is known as your the non-ohmic conductor. So, this is the ohmic conductor and your the non-ohmic conductor. So, this is the graphical form. Next term is you as per your the syllabus, that is resistivity or specific resistance. Resistivity or specific resistance, which is symbol as your the rho. So, as we have written R proportional to L and R proportional to this, means R proportional to your the L by A. This implies R, if you will make it the constant, then if we make it to be equal, then some constant will arise, and that is equals to L by A. And this constant here, it is called your the rho. So, this rho is equals to RA by your the L. So, this rho is known as your the specific resistance or resistivity. So, this resistivity and your the resistance, they are directly related. Means if the resistance will increase, then the resistivity will your the increase. So, this is your the specific resistance. Means how will you define this specific resistance? Specific resistance. Specific means it is derived from the word special, for which we are generally saying that it is a special occasion. That is not the correct, that is a special one. So, this specific means your the special, and resistance as the resistance we have derived. So, this is a specific type, means a special type of the resistance, which is called your the specific resistance. If we will go for its the unit, then what will the unit of that specific resistance? As I said that it depends upon the formula. Formula is your the RA by your the L. So, if we will go for your the MKS, this R means your the resistance. Resistance in the M case we have written that is your the ohm. A means the area. Area unit in your the M case is equals to the meter square by your the L. L is the length, length is the meter. So, meter with the meter square is cancelled. So, that is equals to your the ohm meter. That is in the M case. If we go for your the CGS, this ohm will become your the stat ohm, and meter will become your the centimeter. And if you will go for your the EMU one, then that EMU will have the ab ohm of your the centimeter also. So, this is the unit of your the and the dimension of your unit of your the specific resistance. Okay, thank you.